When adding a neutral bar, it is unlikely you will have a problem with consulting the local electrical inspector ensures code compliance. Here is the procedure. Firstly, shut off the power by turning off the main circuit breaker or disconnecting the service entrance wires before starting work. Secondly, install the new neutral bar by mounting a new 100 amp neutral bar beside the existing one using screws or bolts. Thirdly, bond the neutral bars. Connect the new neutral bar to the existing neutral bar using a solid copper bonding jumper. The size of the jumper should be the same as the neutral conductors, typically number 10 or number 12 AWG. Fourthly, mark the new neutral bar using a permanent marker to label the new neutral bar for identification. Fifthly, connect the neutral conductors by terminating the neutral wires of the additional circuits on the new neutral bar. Sixthly, restore power by turning on the main circuit breaker or reconnect the service entrance wires. Here are some additional considerations. Load balancing. Ensure that the circuits are evenly distributed between the two neutral bars to balance the load and prevent overloading. Grounding. The neutral bar must be connected to the grounding system of the house, typically through the main service panel. Neutral and ground separation. Make sure that the neutral and ground conductors are kept separate and not connected together at any point. Circuit protection. Each circuit connecting to the neutral bar should be protected by a circuit breaker or fuse of the appropriate amperage. Box fill. Ensure that the neutral bars do not exceed the maximum allowable fill in the electrical box. Once the work is complete, have the electrical work inspected by a qualified electrician or inspector to ensure compliance with code requirements. When considering the electrical work, remember a few key points. Firstly, always prioritize safety by de-energizing the circuit before beginning any work. Secondly, use appropriately sized conductors and connectors for the load they will carry, consulting the National Electrical Code or NEC tables for guidance. Thirdly, ensure all connections are tight and secure to prevent loose connections and potential arcing faults. Fourthly, properly ground all metallic enclosures and equipment to minimize the risk of electric shock. Fifthly, label all circuits and components clearly for easy identification and future maintenance. Sixthly, double-check your work to ensure all connections are properly made and that there are no exposed wires or other hazards. Seventhly, consider the future needs of the electrical system when designing or modifying it to avoid future overloads or inadequate capacity. Eighthly, when installing new wiring, use appropriate wiring methods for the environment, such as conduit for exposed locations or non-metallic sheath cable for concealed locations. Ninthly, protect wiring from physical damage by using appropriate protection methods, such as conduit or raceways. Tenthly, follow all applicable codes and regulations to ensure the electrical system is safe and compliant. Now, delving deeper into the specifics of adding a neutral bar, remember that the neutral bar is a crucial component of the electrical system, providing a common return path for current. When adding a neutral bar, it's important to ensure it is properly bonded to the existing neutral system to maintain a low impedance path for fault current. The bonding jumper should be sized according to the NEC table 250.128 based on the size of the largest and rounded conductor serving the panel. When connecting neutral conductors to the neutral bar, make sure to use appropriate connectors that are rated for the size and type of conductor being used. Avoid over-tightening connectors, as this can damage the conductor and lead to loose connections. Also, avoid under-tightening connectors, as this can create high resistance connections and potential hotspots. When terminating neutral conductors, be sure to strip the insulation back to the appropriate length to ensure a proper connection. Do not strip too much insulation, as this can leave exposed conductors that could come into contact with other components. Do not strip too little insulation, as this can prevent the conductor from making full contact with the connector. When installing the new neutral bar, make sure it is securely mounted to the enclosure to prevent it from coming loose and causing a safety hazard. Use appropriate fasteners for the type of enclosure material, such as screws for metal enclosures or bolts for non-metallic enclosures. When connecting the bonding jumper, make sure it is securely connected to both the existing neutral bar and the new neutral bar. Use appropriate connectors that are rated for the size and type of conductor being used. After completing the installation, use a multimeter to verify the continuity of the neutral system and ensure that there are no open circuits or high-resistance connections. Check the voltage between the neutral and ground conductors to verify that the neutral system is properly grounded. In addition to these technical considerations, remember to follow all safety precautions when working with electricity. Wear appropriate personal protective equipment, such as safety glasses and insulated gloves. Use insulated tools to prevent electric shock. Work in a well-lit area to avoid mistakes. If you are not comfortable working with electricity, hire a qualified electrician to perform the work. Now, expanding on the concept of load balancing, it's crucial to distribute the electrical load evenly across the available circuits to prevent overloading any one circuit. Overloading can cause the circuit breaker to trip, disrupting power to the affected area. It can also generate excessive heat, which can damage wiring and create a fire hazard. To balance the load, first determine the total load on each circuit by adding up the wattage of all the appliances and devices that will be connected to it. Then compare the load on each circuit to the circuit's capacity, which is determined by the amperage rating of the circuit breaker. If any circuit is overloaded, redistribute some of the load to other circuits that have available capacity. This may involve moving some appliances or devices to different circuits or adding new circuits to accommodate the additional load. When redistributing the load, consider the location of the appliances and devices to minimize the length of the wiring runs. Shorter wiring runs will reduce voltage drop and improve the efficiency of the electrical system. Also, consider the type of appliances and devices that will be connected to each circuit. Some appliances and devices, such as refrigerators and air conditioners, draw a large amount of current when they start up. These appliances should be connected to dedicated circuits to avoid overloading other circuits. In addition to load balancing, it's also important to ensure that the electrical system is properly grounded. Grounding provides a lower impedance path for fault current to flow back to the source, which helps to protect people from electric shock. The grounding system consists of a grounding electrode, which is typically a metal rod driven into the ground, and a grounding conductor, which connects the grounding electrode to the electrical panel. All metallic enclosures and equipment should be bonded to the grounding system to ensure that they are at the same potential as the ground. This will prevent electric shock in the event of a fault. The grounding conductor should be sized according to the NEC table 250.122. Based on the size of the largest ungrounded conductor serving the circuit. When installing the grounding conductor, make sure it is securely connected to both the grounding electrode and the electrical panel. Use appropriate connectors that are rated for the size and type of conductor being used. After completing the installation, use a multimeter to verify the continuity of the grounding system and ensure that there are no open circuits or high resistance connections. Check the voltage between the neutral and ground conductors to verify that the grounding system is properly grounded. The maximum allowable voltage between the neutral and ground conductors is typically 2 volts. If the voltage is higher than this, it indicates a problem with the grounding system that needs to be addressed. Now, let's discuss the importance of neutral and ground separation. The neutral conductor carries the return current from the load back to the source, while the ground conductor provides a path for fault current to flow back to the source. It's important to keep these two conductors separate to prevent unwanted current from flowing through the ground conductor. If the neutral and ground conductors are connected together at any point other than the main service panel, it can create a parallel path for current to flow. This can cause the ground conductor to become energized, which can create a shock hazard. To prevent this, make sure that the neutral and ground conductors are kept separate throughout the electrical system. Do not connect them together at any point other than the main service panel. Also, make sure that all metallic enclosures and equipment are bonded to the grounding system to ensure that they are at the same potential as the ground. This will prevent electric shock in the event of a fault. Finally, let's discuss the importance of circuit protection. Each circuit should be protected by a circuit breaker or fuse of the appropriate amperage to prevent overloading and short circuits. A circuit breaker is an automatic switch that trips and interrupts the flow of current when the current exceeds a certain level. A fuse is a sacrificial device that melts and breaks the circuit when the current exceeds a certain level. The amperage rating of the circuit breaker or fuse should be matched to the capacity of the circuit. If the amperage rating is too low, the circuit breaker or fuse will trip or blow prematurely, causing nuisance outages. If the amperage rating is too high, the circuit breaker or fuse will not trip or blow in the event of an overload or short circuit, which can damage wiring and create a fire hazard. When selecting a circuit breaker or fuse, consult the NEC tables for guidance. The NEC specifies the appropriate amperage rating for different types of circuits and appliances. Also, consider the type of circuit breaker or fuse that is best suited for the application. There are different types of circuit breakers and fuses that are designed to protect against different types of overloads and short circuits. Some circuit breakers and fuses are designed to protect against instantaneous overloads, while others are designed to protect against sustained overloads. In addition, it is important to consider the box fill. Electrical boxes have a maximum allowable fill capacity, which is the maximum number of conductors and devices that can be safely installed in the box. Exceeding the maximum allowable fill capacity can create a safety hazard by crowding the conductors and devices, which can lead to overheating and short circuits. The maximum allowable fill capacity of an electrical box is determined by the size of the box and the size of the conductors and devices that will be installed in it. Consult the NEC tables for guidance. The NEC specifies the maximum allowable fill capacity for different types of electrical boxes. When calculating the box fill, count all of the conductors that will be entering the box, including the neutral conductors, the grounding conductors, and the equipment grounding conductors. Also, count all of the devices that will be installed in the box, such as switches, receptacles, and lighting fixtures. After completing the electrical work, it is essential to have it inspected by a qualified electrician or inspector. An electrical inspection will ensure that the work has been performed correctly and that it meets all applicable codes and regulations. The inspector will check the wiring, the grounding system, the circuit protection, and the box fill to ensure that the electrical system is safe and compliant. If the inspector finds any deficiencies, they will provide a list of corrections that need to be made. Once the corrections have been made, the inspector will re-inspect the work to ensure that it meets all applicable codes and regulations. A passing electrical inspection is required before the electrical system can be put into service. Ignoring or skipping the inspection step can create a hazardous environment for occupants and also create future financial burdens if something goes wrong. Remember, electrical work can be dangerous, so it is important to take all necessary precautions to protect yourself and others. When working with electricity, always de-energize the circuit before beginning any work. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and insulated gloves. If you are not comfortable working with electricity, hire a qualified electrician to perform the work.